February 1st, 1943. 23,000 feet above Tunis, North Africa. 1347 hours. The grinding shriek of tortured metal echoed through the frozen air as Second Lieutenant Glenn Rojon felt his B-17F, all-American, shudder with an impact that no aircraft was designed to withstand. Above him, impossibly horrifyingly above him, another flying fortress. A Messerschmitt-damaged bomber piloted by Lieutenant Sam Barr had collided with Rojon's aircraft in a mid-air catastrophe that physics and aerodynamics insisted should have sent both planes tumbling to Earth in a flaming death spiral. The sound that dominated the next seconds was not the roar of engines or the whistle of wind through shattered aluminum, but something more primal and more terrifying, the metallic groan of aircraft structures being stressed beyond their engineering tolerances, the acoustic signature of impossible forces acting on machines that had already proven themselves among the most durable combat aircraft ever built but were never meant to survive what was now happening. Rojon's hands gripped the control yoke with white-knuckled intensity as he felt the terrible weight of Barr's bomber settling onto all Americans. Fuselage just behind the radio compartment, the second aircraft's nose and lower fuselage grinding into his bomber's back like a predator's jaws clamping onto prey. The collision had occurred at closing speeds approaching 400 miles per hour during the bomb group's withdrawal from a raid on Bizerte Harbor, when Barr's damaged aircraft, struggling to maintain altitude and control after taking flak damage, had descended directly into the formation's path. The impact had been catastrophic. Barr's bomber's nose and cockpit section had torn through all American's fuselage, shearing control cables, puncturing the tail section structure, and creating a situation that no pilot training, no emergency procedure, no combat experience had prepared either crew for. Two Boeing B-17s locked together in midair, forming an ungainly hybrid that should have been aerodynamically impossible, but was nevertheless flying, or at least not immediately falling, through hostile skies over North Africa. The symbolism of what happened in those next hours. Two American bombers, each crippled and incapable of returning home independently, somehow achieving together what neither could accomplish alone, would resonate far beyond the immediate tactical situation. This was American industrial might made manifest in aluminum and rivets, American engineering philosophy embodied in redundant systems and structural overbuilding, and American determination translated into the refusal of two flight crews to accept the mathematical certainty of their destruction. The sound of those damaged engines still running despite damage that would have killed lesser aircraft became an acoustic testament to the Boeing Company's design philosophy and to the industrial capacity that could produce such machines in quantities sufficient that even catastrophic losses could be sustained and replaced. To understand the magnitude of what Rojon and Barr attempted, one must first comprehend the B-17 Flying Fortress itself and what it represented about American approaches to strategic bombing and to warfare more broadly. The B-17 had been conceived in the mid-1930s as a long-range bomber capable of defending itself with heavy defensive armament while delivering bomb loads deep into enemy territory. By 1943, the B-17F variant that both crews flew represented the matured evolution of that concept. A 4-engine heavy bomber with a crew of 10, armed with up to 13 50-caliber machine guns for defense, capable of carrying 4,000 to 8,000 pounds of bombs depending on mission profile, and possessing a service ceiling above 35,000 feet and a range of approximately 2,000 miles. But the B-17's most significant characteristic was not its armament or range, but its structural resilience. Boeing's engineers had designed the aircraft with redundancy built into critical systems, and with a philosophy that assumed battle damage and designed to survive it. The airframe used a semi-monocoque construction technique where loads were distributed across the structure, meaning that localized damage did not necessarily compromise overall structural integrity. Flight control systems had mechanical backup cables routed through different sections of the aircraft. The 4 Wright R-1820 Cyclone engines could sustain flight even if one or two failed. Fuel tanks were self-sealing. Electrical systems had redundant generation capacity, and the overall design philosophy emphasized survivability through robust over-engineering, rather than through elegance or optimization. This design philosophy reflected broader American industrial and military culture, a preference for machines that could sustain punishment and continue functioning, a willingness to invest additional weight and complexity to improve survivability, and an institutional acceptance that redundancy and overbuilding were worthwhile investments, even when they reduced theoretical performance. German aircraft design, by contrast, often emphasized performance optimization and engineering elegance, producing aircraft that could be exceptional when functioning properly, but that were less forgiving of damage or system failures. The B-17's ability to survive punishment became legendary among aircrews, who flew missions seeing their aircraft absorb damage that would have destroyed more fragile designs and still bring them home. Lieutenant Rojon's All-American had already demonstrated this resilience during previous missions, suffering flak damage that repair crews had patched before returning the aircraft to service. But nothing in Rojon's combat experience or training had prepared him for the situation he now faced. The collision had occurred so suddenly that initial survival instincts, maintaining altitude, preventing a spin, keeping the engines running, took precedence over assessing the full extent of damage. But as the immediate crisis stabilized into merely desperate circumstances, Rojon's crew began reporting damage that seemed incompatible with continued flight. The tail gunner, Staff Sergeant Albert Russo, reported from his isolated position in the tail section that he could see daylight through structural gaps where Barr's aircraft had torn through the fuselage, that control cables were severed and hanging loose, and that the entire tail section was flexing and moving relative to the main fuselage in ways that suggested it was held on primarily by the lower fuselage skin and a few remaining structural members. The tail should have separated completely, should have torn away under the aerodynamic forces acting on it, yet somehow it remained attached, and somehow the vertical and horizontal stabilizers it contained were still providing enough control authority that Rojon could maintain some degree of directional and pitch control. Above All-American, Lieutenant Barr faced his own crisis. The collision had destroyed his bomber's nose section and forward fuselage, had killed or incapacitated crew members in the nose and cockpit area, and had damaged his aircraft's control systems and engines. But Barr's bomber had not fallen away from All-American. The impact geometry and the closing speeds had resulted in the two aircraft becoming mechanically interlocked. With Barr's damaged fuselage resting atop Rojon's, their wreckage tangled together in ways that neither pilot could fully observe, but that both could feel through their control inputs and through the terrible grinding sounds that continued as stressed metal rubbed against stressed metal. The sound of those engines, 8 right Cyclones laboring to keep two battle-damaged aircraft aloft, became the acoustic center of the drama unfolding at 23,000 feet. Each engine's mechanical voice was slightly different, their unsynchronized rotations creating a rhythmic thrumming that rose and fell as pilots adjusted throttles and propeller pitch to maintain altitude and heading. The engines represented American industrial capacity, translated into rotational energy, each one producing over 1,200 horsepower, through precisely machined components manufactured to tolerances measured in thousandths of an inch, assembled in factories that produced aircraft engines in quantities that exceeded total pre-war American aviation production, distributed to combat units across the globe through logistics networks that functioned with systematic reliability despite operating across oceans and continents. Rojon's immediate priority was getting his crippled formation away from hostile territory and toward the relative safety of Allied-controlled airspace. The collision had occurred during the bomb group's withdrawal from the target area, and German and Italian fighter aircraft were still in the vicinity, hunting for stragglers and damaged bombers that could be isolated and destroyed without facing defensive fire from tight formations. The grotesque hybrid of two damaged B-17s flying in tandem would be a tempting target for any interceptor pilot who spotted it, offering the possibility of a double kill against aircraft that clearly could not maneuver or defend themselves effectively. But no interceptors appeared. Whether through luck, weather conditions that concealed the damaged aircraft, or German fighter commanders' decisions to concentrate on other targets, the interlocked bombers flew unmolested through airspace where their survival seemed to depend on remaining undetected. The absence of additional combat allowed both crews to focus on the seemingly impossible task of separating the aircraft and landing them individually, or failing that, of keeping them flying long enough to reach friendly territory where crews could bail out with some hope of rescue rather than capture. Communication between the two aircraft became critical but difficult. Normal inter-aircraft radio procedures were inadequate for coordinating the complex maneuvers that separation would require, and the structural interlocking meant that actions by one pilot would directly affect the other aircraft in ways neither could fully predict. Through trial and error and through communications relayed by crew members who could observe the entanglement from their positions, Rojan and Barr began attempting to separate their aircraft. Through coordinated throttle adjustments and control inputs designed to gradually reduce the mechanical forces holding them together. The process was delicate and terrifying. Sudden movements or aggressive control inputs could cause catastrophic structural failure in either aircraft, could change the aerodynamic balance in ways that sent one or both bombers into uncontrollable spins, or could cause the tail section of All-American to finally separate completely, which would doom Rojan's crew to certain death. The gradual approach required patience and coordination under circumstances where both crews knew that every minute of continued flight increased the risks of structural failure, and that altitude was slowly being lost as the damaged aircraft's aerodynamic efficiency was far below normal operating parameters. After what crew members later estimated as approximately 30 minutes of coordinated maneuvering, though time estimates under such stress are unreliable, the aircraft finally separated. Barr's bomber lifted away from All-American's damaged fuselage, the two aircraft pulling apart with grinding sounds that announced the disengagement of metal from metal, the liberation of both aircraft from the mechanical coupling that had held them together. The separation was gradual rather than sudden, suggesting that the interlocking had been less severe than it felt, though the damage both aircraft had sustained was obviously catastrophic, regardless of how they had been coupled. All-American's tail section, freed from the additional stresses imposed by carrying another aircraft's weight, nevertheless remained dangerously compromised. Rojan discovered that his elevator control was severely limited, that directional control required careful rudder inputs that prevented overshooting and starting oscillations. The damaged structure could not damp, and that maintaining coordinated flight required constant attention and adjustment. The aircraft was flyable in the most technical sense. It responded to control inputs and could be kept approximately level and on heading, but it was not landable in any conventional sense. The tail section's structural integrity was too questionable, the control authority was too limited, and the risk of the tail separating completely during landing approach was too high to attempt bringing the aircraft down with crew aboard. Barr's situation was equally desperate, but differently configured. His bomber had suffered catastrophic damage to the forward fuselage and had lost crew members to the collision. But the aircraft's tail section and rear fuselage remained relatively intact, and the control systems, while damaged, retained enough function that Barr believed he could attempt an emergency landing. The decision both pilots faced was whether to order their crews to bail out over friendly territory or to attempt emergency landings that offered better survival probabilities for the aircraft themselves, but potentially worse outcomes for crews if landings went catastrophically. Wrong. Rojan made the decision that military discipline and crew safety demanded. He ordered his crew to bail out. The tail gunner, Russo, was already isolated in the tail section by the structural damage and would need to bail out through the tail gunner's access door. The waist gunners, radio operator, and other crew members would exit through the waist door or the bomb bay, standard emergency egress procedures that crews trained for but hoped never to employ. Rojan himself, along with his co-pilot and the top turret gunner who could not easily reach alternative exits, would remain with the aircraft until other crew members had safely departed, then would attempt their own bailout if the aircraft remained controllable. The bailout proceeded systematically despite the desperate circumstances. Crew members verified their parachutes, opened the appropriate doors and hatches, and dropped into the cold, thin air at altitude that required immediate attention to avoid hypoxia during the descent. The aircraft, relieved of the weight of departing crew members, became slightly easier to control as Rojan discovered that reduced weight required less elevator authority to maintain level flight. The empty aircraft felt different, quieter without the presence of crew members at their stations, lonelier as the routine sounds of intercom chatter and equipment operation fell silent, more ominous as Rojan realized he was flying a bomber that was essentially a barely controlled wreck being kept aloft through a combination of structural resilience, aerodynamic grace, and pilot skill. Rojan eventually bailed out himself after pointing the aircraft toward open water, where its impact would pose no threat to friendly forces or civilians. All American flew on for several more minutes under its own momentum before the structural damage finally culminated in tail separation, at which point the aircraft tumbled from the sky and impacted the Mediterranean Sea in an explosion of spray and debris that left no recoverable wreckage. The bomber that had absorbed impossible damage, that had carried another aircraft on its back, that had flown long enough to save its crew, had finally exceeded the limits of what even Boeing's over-engineered structure could withstand. Lieutenant Barr faced different calculations with his damaged bomber. The structural damage to his aircraft's forward section was catastrophic, but the rear fuselage and tail remained functional, suggesting that a landing might be survivable if the aircraft could be brought down with enough control to avoid cartwheeling or disintegrating on impact. Barr's crew conducted emergency preparations for crash landing, securing loose equipment, preparing for impact positions, reviewing emergency egress procedures, while Barr nursed the damaged bomber toward an Allied airfield where emergency equipment and personnel would be standing by to respond if the landing went badly. The landing was controlled, but barely. Barr's bomber touched down with limited flap deployment due to hydraulic damage, at speeds higher than normal landing parameters allowed, and with directional control that required continuous rudder inputs to prevent ground looping. The impact was hard but within survivability limits, and the aircraft rolled to a stop on the runway with undercarriage intact and no post-crash fire despite the impact forces and the damage. Emergency crews surrounded the aircraft immediately, helping surviving crew members evacuate and beginning damage assessment that would document the extent of the collisions, effects examination of both aircraft, Rojan's, through crew testimony and through recovery of some debris, Barr's through direct inspection of the damaged but landed bomber, revealed the extraordinary nature of what had occurred. The collision had created damage patterns that engineering analysis suggested should have resulted in immediate catastrophic structural failure, should have caused control losses that made continued flight impossible, and should have overwhelmed even the B-17's legendary structural resilience. Yet both aircraft had continued flying, had separated cleanly without causing additional damage that precipitated final failures, and had flown long enough that most crew members survived through bailouts or through successful emergency landing. The sound of those Wright Cyclone engines, which had continued running throughout the entire ordeal, despite the violence of the collision and the stresses of maintaining flight with damaged airframes, became symbolic of American industrial philosophy and of the engineering culture that had produced the B-17. Their engines represented overbuilding and redundancy. They were powerful enough that four could sustain flight even when airframe damage increased drag dramatically. They were reliable enough to continue operation despite vibrations and stresses that exceeded design parameters, and they were maintainable enough that field service crews could keep them operational, despite the demanding conditions of combat operations in North Africa's harsh environment. The broader strategic context of the Tunisia campaign placed this incident within the larger narrative of American air power's growing dominance and of the industrial capacity that enabled replacement of losses at rates the Axis could not match. The North African campaign had been America's first major ground commitment in the European theater, and the air war over Tunisia tested American tactical doctrines, equipment, and personnel against battle-hardened German and Italian forces. American losses were significant. The learning curve was steep, and the Luftwaffe remained dangerous even as overall strategic trends moved against Germany. But American capacity to replace losses and to sustain operations, despite setbacks, gave the campaign a mathematical inevitability that tactical German superiority could not overcome. The B-17s involved in the collision represented a tiny fraction of American bomber production. Boeing's factories were producing approximately 16 B-17s daily by 1943, with production rates accelerating through systematic application of mass production techniques adapted from automotive manufacturing. The loss of Rojan's aircraft was regrettable, but operationally insignificant because another B-17 would replace it within hours, would be ferried to North Africa within days, and would be flying combat missions within weeks. This industrial capacity to sustain losses and maintain operational tempo was something Axis powers could not match despite tactical proficiency and despite technological innovations that sometimes produced qualitatively superior equipment. German and Italian air forces, fighting in Tunisia, were being ground down through attrition they could not sustain. Luftwaffe units operated with chronic fuel shortages, inadequate spare parts, and pilot replacement rates that could not keep pace with combat losses. The qualitative advantages that German fighters and pilots had possessed early in the war were eroding as American pilots gained experience, and as American production quantities enabled tactics that leveraged numerical superiority. The air war over Tunisia demonstrated that industrial capacity and institutional competence in sustaining combat operations ultimately mattered more than individual aircraft performance or pilot skill. When those advantages could not be maintained across sustained campaigns, the survival of the two B-17 crews, against odds that seemed prohibitively unfavorable, reinforced lessons that American air forces were learning about aircraft design, crew training, and operational doctrine. The B-17's structural resilience was not accidental, but the product of deliberate design choices that prioritized survivability, even when those choices imposed weight penalties and complexity costs. Boeing's engineers had studied combat damage reports, had analyzed failure modes, and had continuously refined the B-17's design through successive variants that incorporated lessons from operational experience. The redundancy that allowed Rojon's aircraft to fly without its tail properly attached was expensive. It required additional structural material, more complex manufacturing, and weight that could have been used for additional weapons or fuel, but it was worthwhile because it brought crews home who would otherwise have been lost. The institutional culture that enabled this continuous improvement was itself significant. American military aviation maintained feedback loops between combat operations, engineering analysis, and production implementation that allowed lessons learned to be incorporated into subsequent aircraft relatively quickly. Damage reports from combat units were systematically analyzed by engineering teams who could recommend modifications and improvements. Manufacturing processes could be adjusted to incorporate design changes without completely disrupting production lines. The entire system operated with responsiveness that German aviation industry, fragmented and disrupted by Allied bombing and administrative chaos, could not match even when German engineers identified necessary improvements. The sound of B-17 engines over Tunisia and throughout the European theater became, for both American aircrews and for Axis forces on the ground, an acoustic symbol of American airpower and industrial might. The distinctive unsynchronized thrumming of four Wright Cyclones identified American heavy bombers before visual contact was made, announced the arrival of formations that could deliver thousands of tons of ordnance on strategic targets, and communicated to everyone within audible range that American material superiority was not propaganda, but observable reality. For German defenders, the engine sound marked approaching destruction that could be contested but not prevented, that could be made costly through anti-aircraft defenses and fighter interception, but that would ultimately accomplish its mission because American capacity to sustain losses exceeded German capacity to inflict them. The crews who survived the collision and separation became symbols themselves of the resilience that characterized American military culture, of the technical competence that enabled impossible achievements, and of the refusal to accept defeat, even when circumstances suggested that survival was mathematically impossible. Rojon and Barr both received decorations for their actions, though both insisted that survival had been a combination of skill, aircraft resilience, and improbable luck rather than heroism in any traditional sense. The crew's survival testified to training quality. They had executed emergency procedures correctly under extreme stress, had coordinated complex actions despite communication difficulties, and had maintained discipline when panic would have been understandable. The broader statistical context of B-17 operations placed this incident within patterns that validated the strategic bombing campaign's logic even when individual missions demonstrated its costs. American heavy bomber losses over Europe averaged approximately 5% per mission during the worst periods of 1943, rates that were unsustainable over extended campaigns, and that led to the introduction of long-range escort fighters like the P-51 Mustang. But even during this brutal attrition, American bomber forces maintained operational tempo because production replaced losses and because crew training pipelines maintained adequate replacement rates for the grim arithmetic of aerial warfare. The B-17s. Legendary status among American air crews was not purely mythological but was grounded in statistical reality and in countless incidents where the aircraft's structural resilience enabled survival. The Air Force's official history documented thousands of cases where B-17s returned from missions with damage that seemed incompatible with continued flight: missing tail sections, destroyed engines, massive structural damage, yet managed to bring crews home through combination of robust design and pilot skill. The Rojan bar collision and survival was extreme but not unique in demonstrating what the aircraft could withstand when circumstances demanded impossible performance. The symbolic significance of the engine, sound, that steady multi-tone thrumming that marked B-17 operations throughout the war, extended beyond its immediate acoustic properties to represent broader truths about American war-making capacity. Each engine represented industrial supply chains that extracted aluminum from bauxite, forged steel from iron ore, manufactured precision bearings and fuel injection systems, and assembled complex machinery using production techniques that made aircraft engines as reliable as contemporary automotive engines. The logistics networks that kept those engines supplied with fuel, with oil, with spare parts, with maintenance expertise operated across oceans and continents with systematic reliability that testified to institutional competence in managing complexity at scales that exceeded anything previously attempted in human history. As the North African campaign concluded with Axis surrender in Tunisia in May 1943, as American bomber operations expanded through Sicily and Italy and prepared for the strategic bombing offensive against Germany proper, the lessons learned from incidents like the Rojan bar collision continued informing doctrine and equipment development. The B-17 would be supplemented and eventually replaced by the B-24 Liberator, and later by the B-29 Superfortress, each representing evolutionary improvements in range, payload, and defensive capabilities. But the B-17's legacy persisted through the war and into post-war military aviation. Its influence visible in the continued emphasis on crew survivability, structural redundancy, and robust overbuilding that characterized American military aircraft design philosophy through subsequent decades. In the final accounting of World War II's air war, incidents like the mid-air collision and improbable survival of two B-17s mattered less for their individual tactical significance than for what they revealed about the systematic advantages that characterized American war-making capacity. The aircraft survived impossible damage because they had been designed to survive impossible damage, because American industrial culture could afford the weight penalties and complexity costs that survivability required, and because systematic feedback between combat experience and engineering improvement enabled continuous refinement of already excellent designs. The crews survived because they were well trained, because their equipment was reliable, because rescue and recovery infrastructure could retrieve them from hostile territory, and because the broader military system valued individual lives enough to invest resources in maximizing survival probabilities even when such investment reduced theoretical operational efficiency. The sound of those Wright Cyclone engines, laboring to keep damaged aircraft aloft through hostile skies over Tunisia, echoes through history as testimony to what American industrial democracy achieved when fully mobilized for existential conflict. The engines represented more than mechanical assemblies. Converting fuel into rotational energy, they represented a society's productive capacity organized through market mechanisms and corporate structures that proved more effective at sustained industrial effort than authoritarian alternatives despite theoretical advantages of centralized planning. They represented institutional competence in managing complex systems, in maintaining quality control across massive production scales, in coordinating supply chains that spanned the globe. They represented values that treated individual crew members as worth saving, that invested resources in redundancy and overbuilding to improve survival odds, that accepted reduced theoretical performance in exchange for practical resilience. When two B-17s piggybacked through enemy skies and somehow survived, they demonstrated truths that transcended their immediate tactical situation. They showed that American aircraft were built to survive punishment, that American crews were trained to handle emergencies, that American industrial capacity could sustain losses and maintain operational tempo, and that American institutional culture valued individual lives and crew survivability in ways that influenced equipment design and operational doctrine. The improbable survival became symbol of larger strategic realities, that industrial democracies could organize resources more effectively than totalitarian alternatives, that material advantages ultimately determined outcomes in industrial warfare, and that societies organized around individual dignity and institutional competence possessed advantages that tactical excellence and ideological fervor could not overcome. The engines thrumming ceased when both aircraft finally succumbed to damage. One ditching in the Mediterranean, one landing damaged at base, but the sound's symbolic resonance persisted through the war and beyond. It represented the industrial symphony that American factories performed daily, producing weapons at scales that transformed quantity into quality, that made losses sustainable and victory mathematically inevitable once industrial capacity was fully engaged. It represented the values that shaped American military culture: emphasis on survivability, investment in training and equipment, respect for individual lives, and systematic competence in managing complexity. Most fundamentally, it represented the sound of democracy at war, of free societies mobilizing for existential conflict, of industrial abundance enabling both military effectiveness and relative restraint, of power tempered by values that persisted even in warfare's most desperate circumstances. The two B-17s that flew, piggybacked through African skies, carried more than ordnance and crew. They carried evidence of what American industrial civilization could achieve when challenged, proof that democratic values and industrial might were complementary rather than contradictory, and testimony that sometimes impossibility was merely the frontier, that determination, skill, and over-engineered aluminum structures could push beyond when survival demanded it.